What was the climate like during the age of dinosaurs? Welcome to the Natural History of Dinosaurs. My name is Benjamin Berger. I'm a paleontologist teaching at Utah State University in the heart of Utah's dinosaur country in Vernal.
I'm standing in a world that the dinosaurs never experienced. Throughout the Mesozoic era, the Earth experienced one of the longest periods of time without significant ice ages. There's no geological evidence to suggest that glaciers were ever present during the Mesozoic era. And the Earth was tropically warm and nearly homogeneous in its climate from pole to pole. During the Triassic and early Jurassic, there were vast deserts. But the time period of the late Jurassic and the Cretaceous was warm, wet, and tropical. But how do we know this? What are the fossilized clues for this warm climate during the age of dinosaurs? Well, it's found in fossils such as this one. This is a fossil conifer branch found here in northeastern Utah alongside Cretaceous dinosaurs. But this is not any typical conifer like the conifer trees that surround me. This is a close relative to the Araucarian pine tree called the Norfolk Island pine. The scientific name, Araucaria heterophylla. Hetero meaning different, and phylla meaning leaf. And here we see in this fossil the two different intertwined needles. Today, the species is only found native on an isolated island in the South Pacific, the North Fork Island, where it grows in the warm South Pacific waters. Now we can assume perhaps that the presence of this fossil plant as a fossil here in the snowy landscape of Utah indicates a warm tropical climate like the tropical climate of the South Pacific today during the Cretaceous period around 70 million years ago. And now it's hard to think of a more remarkable difference between two such different climates.
Fossil plants are a useful method for understanding the climate during the age of dinosaurs. And much of that is due to the fact that many plants that lived during the age of the dinosaurs are still around today. And we can look at their modern habitat preferences and use that knowledge to determine the climate of the past. Fossil plants can tell us how much seasonal rain fell, if the temperatures ever dropped below freezing in the winter, and even the density of the forest canopy. Now there's one other tool besides fossil plants that paleontologists can use to determine the climate of the past, and that is looking at the chemistry of marine fossils. This method was discovered by a brilliant scientist named Harold Urey, who earned a Nobel Prize in chemistry for his work on chemical isotopes. Now, Urey had worked during World War II on the radioactive isotopes involved in uranium enrichment. Now remember, isotopes are elements with the same number of protons but different numbers of neutrons. Now, because they share the same number of protons, they have the same chemical properties, but they differ in mass because of the different numbers of neutrons. Now, increasing a mass of an element by just adding lots of neutrons can eventually make the element radioactive, such that the atom explodes, it emits energy. But after World War II and the atomic sort of revolution of that war, Urey became more interested in the stable isotopes. These are the isotopes that don't fall apart, but they remain stable forever. Now, his Nobel Prize was in the discovery of deuterium. Now, deuterium is an isotope of hydrogen. It's the only stable isotope that actually has its own distinct name, but one that you don't find on the periodic table of elements. Deuterium is hidden because it's basically a hydrogen atom with the addition of a neutron. So it behaves just like hydrogen. In fact, you likely have some deuterium in your body, and the next time you drink a glass of water, a few of those hydrogen atoms will be deuterium. Now, it's a stable isotope, so it won't break down or break apart. Now, Urey was interested in how different isotopes become enriched or depleted in living animals, and believed in the case of oxygen isotopes, it might be related to temperature. So he devised an experiment, and in his experiment he grew clams in aquarium tanks at different water temperatures. And then he measured the ratio of isotopes in the oxygen found in the shells of those clams. And what he discovered was that the oxygen isotopes in the shells of the clams was correlated to the temperature of the water that they grew in. And this is a major discovery, because then you could take fossil clams with some of the original shell preserved and then measure the oxygen isotopes in the shell, and using a simple formula could calculate the temperature of the water that it grew in. Now, over the last 60 years, scientists have used this as a proxy, as a paleontological thermometer, and studies of Mesozoic marine life suggest that the ocean waters during the age of the dinosaurs were warm and tropical throughout the entire Mesozoic era. Now, these lines of evidence, both of fossil plants as well as these stable isotopes, these chemical analysis, suggests that the age of dinosaurs was one of the longest periods of warm tropical climates on Earth. And there was very little latitudinal differences in temperature and climate. It may have been that the dinosaurs never got to experience snow and ice. All right, now you should be able to evaluate the two methods of determining climate for the Mesozoic era. That is, using stable isotopes or using the occurrence of fossil plants.